Hey there, welcome to a video on systems of equations, specifically in three variables. While these systems could have one solution, infinite solutions, or no solution, all the examples I'm going to be doing in this video all have one solution. While I'll give you the equations for the first four examples, the fifth example is an application word problem where we'll have to figure out the system of equations. Let's get into it. A common strategy I'll be using throughout this video is that I'll be labeling each of my equations to keep track of them. I'll always call the first original equation equation A, I'll call the second original equation equation B, and I'll call the third original equation equation C. Right away, I do notice that none of the equations have all three variables, which is good news for us. In fact, one of the equations even only has one variable. Because equation B only has one variable, we can solve for C very quickly. Equation B is negative 3c is equal to 12, and if we divide both sides by negative 3, negative 3c divided by negative 3 is just c, and 12 divided by negative 3 is negative 4. C equals negative 4 is going to be part of our answer. 1 down, 2 to go. Now that we have C, we still need to solve for A and B. We're not going to look at equation A right now because it doesn't even have a C in it. However, equation C does have a C in it. If we substitute C equals negative 4 into this third equation, we can solve for B. Substituting in, we're going to get 6b plus 5 times negative 4 is equal to 10. Since 5 times negative 4 is negative 20, we're going to get 6b minus 20 is equal to 10. I'm going to add 20 to both sides, and we're going to get 6b is equal to 30. If we divide both sides by 6, we're going to get b is equal to 5. Now that we have B and C, we just have to solve for A. We're going to use equation A because it's the only equation that has A in it. There's only two variables in equation A, and we already know what one of them is. We're going to substitute 5 in for B. Substituting in, we're going to get 5A plus 2 times 5 is equal to 0. Since 2 times 5 is 10, we're going to get 5A plus 10 is equal to 0. Subtracting 10 from both sides, we're going to get 5A is going to be equal to negative 10. 5a divided by 5 is going to be a, and negative 10 divided by 5 is going to equal negative 2. When writing our final solution, we're going to write it in the order of a, b, c. So in this case, it's going to be negative 2, 5, negative 4. The nice thing about systems is that you can plug in your solutions to see if they work. Let's try another one here. First, I've labeled my original equations A, B, and C. This system isn't as nice as the last one because each of the equations has all three variables. Our first goal is going to be eliminating one of the variables so that we have an equation with just two. One potential option is adding equations A and B to eliminate the y's. Another idea is to use equations A and C where we can subtract these equations to eliminate the three z's. In this problem, it's my preference to add equations A and B to eliminate the y's. Rewriting the equations, we have 2x plus y plus 3z is equal to negative 2, and we have x minus y minus z is equal to negative 3. Adding these two equations together, 2x plus x is going to be 3x, y plus negative y gets eliminated, 3z plus negative z is going to be positive 2z, and negative 2 plus negative 3 is going to be negative 5. This new equation that just has variables x and z, I'm going to label equation D. Now our next goal is to create another equation that just has x and z that looks like equation D. Since we've already used equations A and B together, we have the options of using B and C or A and C. Here, I'm going to use the equations B and C because B has smaller coefficients. To eliminate the y's in equations B and C, I'm going to have to multiply equation B by 2. In doing so, equation B is now going to become 2x minus 2y minus 2z is equal to negative 6. Equation C is just going to stay the same as 3x minus 2y plus 3z is equal to negative 12. Subtracting these two equations, 2x minus 3x is going to be negative x, negative 2y minus negative 2y gets eliminated, negative 2z minus 3z is negative 5z, and negative 6 minus negative 12 is equal to positive 6. I'm going to call this new equation equation E. Now we're going to use equations D and E to solve for one of the variables. Working with equations D and E should be a little bit more comfortable since it just has two variables like a linear system. Since multiplying the bottom equation by 3 is going to be easier, I'm going to do that. Equation D is going to stay the same as 3x plus 2z is equal to negative 5, but equation E is going to become negative 3x minus 15z is equal to 18. If we add these two equations together, 3x plus negative 3x gets eliminated. 2z plus negative 15z is going to be negative 13z, and negative 5 plus 18 is going to be positive 13. Dividing both sides by negative 13, we find out that z is going to equal negative 1. Now we can take the z value of negative 1 and plug it into either equation D or equation E to solve for x. I'm going to go with equation D because there's less negatives. Substituting into D, we're going to get 3x plus 2 times negative 1 is going to equal negative 5. 2 times negative 1 is negative 2, so we're going to get 3x minus 2 is equal to negative 5. We're going to add 2 to the left and add 2 to the right, and we're going to get 3x is equal to negative 3. Dividing both sides by 3, we're going to get x is equal to negative 1. Now that we have two of the three variables, we can plug them either into equation A, equation B, or equation C. Any of them will help us solve for y. Let's use equation B because it has easier coefficients. Substituting into equation B, we're going to get negative 1 minus y minus negative 1 is equal to negative 3. Simplifying this equation down, we're going to get negative 1 minus y plus 1 is equal to negative 3. If we combine the negative 1 and positive 1 on the left side, we just get 0. This simplifies down to negative y is equal to negative 3. Multiplying both sides by negative 1, we find that y is equal to positive 3. Now we have all three variables. The solution to this system is going to be negative 1, 3, negative 1. Again, feel free to plug in these solutions to see if they work. In this next example, we have some equations with some higher coefficients. While these coefficients are a little higher, it is nice that they're all even numbers. Finding common multiples of terms won't be too bad. I don't think I'm going to be trying to eliminate the x's since one of the coefficients is so big. I'll probably stay away from the y's since 24 is the first time each of these coefficients meet. I think I'm going to go with the z's here since they match in equations b and c, and I just have to multiply equation a by 2 to also get it to match. Here we're going to write equations b and c and add them together. We have 2x plus 8y plus 4z is equal to 32, and we have 30x plus 12y minus 4z is equal to 24. Adding these two equations together, 2x plus 30x is going to be 32x, 8y plus 12y is going to be 20y, 4z plus negative 4z gets eliminated, and 32 plus 24 is 56. While I could leave this equation alone, I'm going to divide the whole thing by negative 4 to deal with smaller numbers. 32x divided by 4 is going to be 8x, 20y divided by 4 is going to be 5y, and 56 divided by 4 is going to be 14. Using these lower numbers may be less work later on. Now that we have an equation with just x and y, let's try to find another equation with x and y. Now I'm going to use equations a and b to eliminate the z's. To eliminate the z's, we're going to have to multiply the whole top equation by 2. When we do that, equation a is going to become 8x plus 4y minus 4z is equal to 20, while equation b stays the same as 2x plus 8y plus 4z is equal to 32. 8x plus 2x is going to be 10x, 4y plus 8y is going to be 12y, negative 4z plus 4z gets eliminated, and 20 plus 32 is going to be 52. Dividing this whole equation by 2, we get an equation of 5x plus 6y is equal to 26. We'll call this equation E. Notice how equation D and E both have just x's and y's. In looking at equations D and E, I feel like eliminating the y's. To do that, I'm going to multiply equation D by 6 and multiply equation E by 5. Once we do that, equation D is going to be 48x plus 30y is equal to 84, and equation E is going to be 25x plus 30y is equal to 130. Subtracting these two equations, 48x minus 25x is going to be 23x, 30y minus 30y gets eliminated, and 84 minus 130 is going to be negative 46. Dividing both sides by 23, we find out that x is going to equal negative 2. Now let's plug in our x value into equation D or E to solve for y. I'm going to go with equation E. Substituting into E, we're going to get 5 times negative 2 plus 6y is going to equal 26. 5 times negative 2 is negative 10, so we have negative 10 plus 6y is equal to 26. If we add 10 to both sides here, we're going to get 6y is equal to 36, and divide both sides by 6, we're going to get y is equal to 6. Now that we have x and y, let's plug it into one of the original equations to solve for z. I'm going to choose to plug them into equation A. Substituting in, we're going to get 4 times negative 2 plus 2 times 6 minus 2z is going to equal 10. 4 times negative 2 is going to be negative 8, and 2 times 6 is going to be 12, minus 2z is equal to 10. Adding together this negative 8 plus 12 is going to be positive 4, minus 2z is going to equal 10. Subtracting 4 from both sides, we're going to get that negative 2z is going to equal 6, and dividing both sides by negative 2 is going to say z is equal to negative 3. The solution to this system is going to be negative 2, 6, negative 3. Right from the beginning, this system looks a little bit messy. Notice that the form for each equation is a little bit different and none of the variables line up. Let's first spend a moment rearranging each of the equations so they're easier to use. For equation A, I'm going to start off by adding c to the right side and adding c to the left side. From this, we get 0 is equal to negative 3 plus 3a minus 2b plus c. Next, I'm going to add 3 to the right side and add 3 to the left side. Doing this is going to give us 3a minus 2b plus c is equal to 3. Now equation A is organized. Since equation B was already in this form, we're just going to leave it alone. For equation C, I'm going to add 8b to the right side and add 8b to the left side. From that, we're going to get 3a plus 8b is equal to negative 2 plus 2c. Next, let's subtract 2c from the right side and subtract 2c from the left side. And that'll give us 3a plus 8b minus 2c is equal to negative 2. Now all three equations are in the same form. And here are all the rewritten equations. In this system, I'm going to work on eliminating the c's since their coefficients are the easier ones to deal with. I'm going to start with the equations a and b, and I'm going to multiply equation a by 4 so that the c's coefficients will match. When multiplying equation a by 4, we're going to get 12a minus 8b plus 4c is going to equal 12, while equation b is going to stay the same as negative 7a plus 2b plus 4c is equal to 22. When subtracting these two equations, 12a minus negative 7a is going to be 19a, negative 8b minus 2b is going to be negative 10b, 4c minus 4c is going to be eliminated, and 12 minus 22 is going to be negative 10. This will be equation D. Now I'm going to use equations b and c to eliminate the c's. To do that, I'm going to have to multiply equation c by 2. Let's rewrite these equations. Equation b is going to stay the same as negative 7a plus 2b plus 4c is equal to 22, but our new equation c is going to be 6a plus 16b minus 4c is equal to negative 4. Adding these two equations together, negative 7a plus 6a is going to be negative a, 2b plus 16b is going to be 18b, 4c plus negative 4c is going to be eliminated, and 22 plus negative 4 is going to be 18. This will be our equation E. Now let's work with equation D and E. I'd like to eliminate the b's. In order to do so, I'm going to have to multiply the top equation here by 9 and multiply the bottom equation here by 5. In doing so, we're going to get a coefficient of 90 for both equations. Our new equation D and E is going to be 171a minus 90b is equal to negative 90, and negative 5a plus 90b is equal to 90. Let's add these two equations. 171a plus negative 5a is going to be 161a. Negative 90b plus 90b is going to be eliminated, and negative 90 plus 90 is going to be 0. Dividing both sides by 161, we're going to find out that a is equal to 0. I'm going to plug this value into equation E to solve for b. Substituting in, we're going to get negative 0 plus 18b is equal to 18. Negative 0 is just 0, so we're going to have 18b is equal to 18. And dividing both sides by 18, we're going to get b is equal to 1. Finally, let's plug in our values of a and b into one of the original three equations to solve for c. Since c is basically already isolated in equation A, I'm going to use that one. Substituting in, we're going to get negative c is equal to negative 3 plus 3 times 0 minus 2 times 1. Negative c is equal to negative 3 plus 3 times 0 is just 0, and negative 2 times 1 is going to be negative 2. Negative c is equal to negative 3 plus 0 is just going to be negative 3 minus 2, and negative c is equal to negative 3 minus 2, which is negative 5. Multiplying both sides by negative 1, we find that c is equal to 5. The solution to this system is going to be 0, 1, 5. Here we have an application word problem. Mr. Lee gives out a lot of Jolly Ranchers to his students. In his career, Mr. Lee has bought 350 bags of Jolly Ranchers. Small bags cost $4.50, medium bags cost $7.50, and large bags cost $12.50. Mr. Lee has bought half as many large bags as medium bags. If he has spent $2,415 on Jolly Ranchers, how many small, medium, and large bags has he bought? Since there are 3 unknowns in this problem, let's set up 3 variables to represent them. I'm going to have x represent the small bags, y represent the medium bags, and z represent the large bags. Now that we've defined our variables, let's try to set up 3 equations to find these 3 variables. Since only small, medium, and large bags were bought, these must add up to 350 bags in total. To represent that, we can write x plus y plus z is equal to 350. Then we notice we have the cost of each size bag and the total cost of all the bags. To represent the cost of the bags, we can write 4.5x plus 7.5y plus 12.5z is equal to 2,415. 4.5x represents the total cost of all the small bags, 7.5y represents the total cost of the medium bags, 12.5z represents the total cost of the large bags, and 2,415 represents the total cost of all the bags. The last bit of information we're told is that Mr. Lee bought half as many large bags as medium bags. As an equation, we can say that z is equal to y divided by 2. If we take the number of medium bags, y, and we cut them in half, we should get the number of large bags, which is z. To make this equation a little bit easier to work with, we can multiply the right side by 2 and multiply the right side by 2. In doing so, we're going to get that 2z is equal to y. Now we have a system of 3 equations. We can label them A, B, and C. What's really nice about this system is that we already have y isolated. Since y is equal to 2z, we can substitute y for 2z in equation A, and we can substitute 2z for y in equation B. Once we do that, we're going to get x plus 2z plus z is equal to 350, and we get 4.5x plus 7.5 times 2z plus 12.5z is equal to 2,415. By combining like terms in equation A, we can simplify to get x plus 3z is equal to 350. Now let's simplify equation B. 7.5z times 2z is going to be 15z, and 15z plus 12.5z is going to be 27.5z. Equation B is now going to be 4.5x plus 27.5z is equal to 2,415. Here we have our equations D and E. I think it's going to be easier to multiply the whole top equation by 4.5, so we could eliminate the x's and solve for z. Our new equation D is going to be 4.5x plus 13.5z is equal to 1,575. Equation E is going to stay the same as 4.5x plus 27.5z equal to 2,415. 4.5x minus 4.5x is going to be eliminated. 13.5z minus 27.5z is going to be negative 14z, and 1,575 minus 2,415 is going to be negative 840. Dividing both sides by negative 14, we're going to find out that z is equal to 60. Now that we know that z is equal to 60, we could plug it into this equation here to solve for y. Substituting in, we have 2 times 60 is equal to y, which means y is equal to 120. Now that we know the values for y and z, we can substitute them in here and here in equation A to solve for x. Substituting into equation A, we get x plus 120 plus 60 is equal to 350. Adding 120 and 60, we're going to get x plus 180 is equal to 350. Subtracting 180 from both sides, we find out that x is equal to 170. The solution to our system is going to be 170, 120, 60. Remember that 170 represents x, 120 represents y, and 60 represents z. In conclusion, we found that there were 170 small bags, 120 medium bags, and 60 large bags. Hopefully Mr. Lee's students enjoyed all those Jolly Ranchers. Thanks for sticking around to the end. I hope you found this video useful in understanding systems with 3 variables better. Keep up the good work, and I'll see you in the next one.